Okay, we're going to look at this important experiment, which is to see how does the height of a ramp affect the average speed of an object down that ramp. Before we even think about writing methods or apparatus or what will happen in this experiment, we should always think about our variables. And the first variable we look at is the independent variable, which is the thing we're going to change. We're going to set it to certain values and see what effect that has on the experiment. And in this case, the thing that we're going to change is the height of the ramp. What we then want to see is what is that going to have an effect on? And in this case, we will need to measure this to determine what that quantity is, and we want to see what will be the average speed of the object down that ramp. Now, that then leads us on to think, well, we can't measure average speed directly, so we're actually going to have to measure two quantities to calculate this. So we're going to have to measure both the distance that the object travels down the ramp and the time that that takes. And finally, every time we change the height of the ramp and measure the average speed, we need to keep certain things the same, okay? Those things are called control variables. It ensures it remains a fair test. By that we mean if we find out the object gets faster, we want to know that it's changing the independent variable that caused that to happen. If we change more than one thing, then we won't be able to tell which of those things it was caused the speed to increase. So in this case, the important things that we need to keep the same are the length of the ramp, the truck, so it's the same mass each time, and there's no more friction as it moves down there, the surface of the ramp. Okay, once we've worked out what all our variables are, we can then begin to think about what apparatus are we going to need to carry out this experiment. Now, if we're trying to see how the height of a ramp affects the average speed of an object down it, we're going to need some very obvious things like a ramp and a truck to move down it. But after that, then we need to begin to think about, okay, well, what am I going to change? So in this case, we're going to change the height of the ramp. So we're going to use a lab jack to do that, but feasibly you could just use textbooks and add more textbooks underneath the ramp. We need to measure the average speed of the truck down the ramp. So we're going to need a meter rule to measure the distance and a stopwatch to measure the time. It's also good to mark the things you're going to measure on the diagram. So this diagram now tells us exactly where we're going to measure the height. It also tells us that we're going to have a starting line and finish line that are 2 meters apart. So that just makes it clear to anyone who's looking at the diagram exactly what they have to do. Okay, let's look at something a lot of people find difficult, which is writing methods to experiments. For experiments, we want to see how one variable affects another, which is most of the experiments we look at GCSE physics. We can use this type of structure to help us just give a little bit of scaffolding to how we write our methods. So first step is set up the apparatus as shown in the diagram. Second step, we set our initial value for our independent variable. Next, we measure the dependent variable. Then we go back and we take more readings, but change the independent variable to other values. And then after that, we always repeat our results and take an average. No matter what happens in a method, we always add in that step. Even if you're not too sure that you're going to get full marks in the other bits, make sure you put that in because that will be worth a mark in the exam. And then lastly, we draw a graph or do something with our results to prove what we were trying to prove. So let's look at how that scaffolding applies to this particular experiment. So first step is always this one. Sometimes we have to do things differently, but in this case we've got a good diagram, shows the person how to set up the apparatus. Because of that diagram, it actually saves us writing an awful lot in our method because we can just say set it up exactly as it is shown. Second step is to set our independent variable to the initial value. Our independent variable is the height of the ramp. So we just take some value and say set it, in this case, to 2 centimeters tall. Say how we do that. If we are going to know that it's 2 centimeters, we're going to have to make sure that it is by using a ruler. We would also in this step set other things that need to be set. So in the case of this experiment, we want to keep the control variable of the length that it runs down the ramp the same. So we draw a start and finish line, measure 2 meters apart before we start on to the next part. So the next thing we do is we measure the dependent variable. Now the dependent variable is average speed. So to do that, we've always already set the distance, but we're going to actually have to measure a time to calculate the average speed. So in this case, we place the truck, so the front of the truck is in line with the start line. We release the truck at the same time as starting the stopwatch. So you can see if we're ever measuring anything, we always state what piece of equipment we're going to use to measure that. And then we stop the stopwatch when it passes the finish line. We now have that one result for the height of the ramp being at 2 centimeters, but we want to see how changing the height of the ramp affects the average speed. Therefore, we go back and we do step 4 again, but we change the height of the ramp by 2 centimeters each time up to 12 centimeters. So we should always get at least 5 different readings for our independent and dependent variables. You can also see in this step, we say we go back, try it at different heights, but keep all these things the same. So someone reading this method would know what the control variables are in this experiment. Like I said, we always put this step in, so we go back and repeat our readings twice more and take an average of all the times. And then we state what we do with our results. So in this case, we want to see how the height affects the average speed, but we've just measured the time. So we have to tell the person you're going to need to calculate the average speed. And how you do this is you use the distance that has gone down the ramp. So in our case, we say that's 2 meters, and we divide it by the time. And then if we need to, we state which graph we draw to show our results more clearly. Okay, let's look at the results for this experiment then. You can see that we have our 6 different heights, and at each of those heights we have 3 readings for time and then an average. Now there's some important things to look at in this results table. First one is when we're taking an average, so if we look at this line, you should see we have 3.16, 3.16 and then 1.36. That is that far away from the other 2 results. We would circle that, say it's an anomaly, and ignore it when it comes to working out this average here. The other thing to note is if we look at this line, the first reading was 3.66, second reading was 3.65, third reading was 3.65. When we take an average of those results, we actually get 3.653333 reoccurring. Okay. However, our first one was the 3 significant figures. Second one was the 3 significant figures. Third one was the 3 significant figures. So we should round this down and just give it to 3 significant figures in the table of results. Now, looking at those results, I can make a very, very quick conclusion, which is as we increase the height of the ramp, the average speed down that ramp increases. Now, if we want to make a better conclusion than that, we would need to draw a graph. If we look at a graph of our results, you can see we've got the independent variable, the height of the ramp, along the x-axis here, and our dependent variable, the average speed of the truck down it, on our y-axis. You can also see we have our units for each of those labeled. We have a nice scale that's big enough that the graph takes up more than half the page. And when we plot the points then, we should look and see it doesn't really look like a straight line. There is a curve to it. So we draw a nice smooth curve through those points. And then from that graph, I can tell that as the height of the ramp increases, we can kind of see that the average speed also increases. However, one of the things I can notice about this is, firstly, it's a curve, but also, even if I was to extend it over to the y-axis, it doesn't cut through the origin. So for those 2 reasons, I know that it's not directly proportional, because to be directly proportional, it has to be both a straight line, and it also, on top of that, has to go through the origin. Our conclusion for experiments always start the same way. So we describe what happens to the dependent variable when we change the independent variable. So we just take this sentence as the independent variable increases, and then we describe what happens to the dependent variable. So it either increases, decreases, or stays the same. And we just change it to suit our experiment. So in this case, the independent variable is the height of the ramp, and the dependent variable is the average speed. And what we found out was that as the height of the ramp increases, the average speed also increased. Um, we can then give a more detailed description of that, because what we found out was that the graph was not a straight line and it didn't go through the origin. Therefore, those two variables are not directly proportional.